Yeah, thank you very much for the introduction. I hope I can match the presentation of my person. The general situation of today is we are in a race against time in shifting to renewable energies and to replace the conventional energies. That means to replace fossil and atomic energies. This is possible. The possibility is denounced up to now by the protagonists of the conventional energy system. The protagonist of the present energy system creates the myth of an indispensability of the present power structure. But there are some existential limits of the present energy system, which is more or less a fossil and in some countries an atomic energy system. The limits are obviously the limits of the reserves is one, and nobody can contradict to the fact that these energies runs out. And the time of running out is very short, because we have increasing energy needs in the world. Look to the development in China and India. More than 2 billion people live there, 1/3 of world population. And up to now they have an energy need of perhaps 15% of the energy needs in the so-called Western industrialized countries. And if they will get the same standard of energy consumption like we, perhaps the exhaustion of oil will take place in 3 decades, possibly in 4 decades. But 10 years more or less don't make a difference in principle. We have the situation that the curve of the reserves, of the conventional reserves, is going down in the next decades, mainly for oil, for natural gas, and for uranium. And the curve of energy demand is going up. And if these two curves arrive at a crossing point, the world will get its final conflict. Nothing works without energy, and the energy wars have still begun. The Iraq War or the Gulf War would not happen if there would be the plantation of bananas at the Arabian Peninsula instead of the extraction of oil. There's no other reason for the conflict there. 60% of the world oil production annually comes from only 40 giant fields. 30 of them are in the Islamic states from Central Asia, like Turkmenistan, to the Caucasus, like Kazakhstan, to Iran, the Arabian Peninsula, and North Africa, Nigeria, Sudan, Libya. And this creates more and more vulnerability. And practically the whole world is looking to these sources. And in the gas, in natural gas, we have more dependency than less. And uranium, we have more dependency than less. And coal is a little bit more widespread, but who can imagine that the whole world will change from oil and gas again to coal. And then the coal reserves will smelt very, very, very fast. If this would happen. That means we are in a race against time. Because without energy nothing works. And the time limit, the ecological time limit, is closer than the reserve time limit. Because we are not allowed to burn off all the well-known reserves. The idea to prolongate the conventional energy structure with so-called non-conventional fossil energies is stupid, because this would create more environmental damages, and it would lead to much higher costs, to much more water consumption. And the water resources are again an ecological limit, more and more. There are three main water-consuming sectors in the world. One are the cities, second, the agriculture, third is the conventional energy system. And the scarcity of water is one of the ecological limits and physical limits in general of the present energy system. And because the limitation by the ecosphere, because it is already overstressed, is closer in the time scale than the limits of the reserves, we must be aware of a situation that we have to replace in the next decades the present energy system by renewable energies. And this creates a new energy system. It is impossible to change to renewable energies in the same structures like the present energy system represents. Because an energy system, an energy economy, with all its technologies, can never be neutral to all the different energy sources. An energy system must be tailored to the flow of the energy which is used today. The decision about an energy is a decision about the question, is the energy far away or it is close to the needs? It is a decision about are there mining and extraction technologies needed or not. It's a decision about which infrastructure for the energy transport is necessary. Or don't we need that? It's a decision about the kind of energy conversion technologies which must be used to transform the primary energy into the final energy which should be consumed by the customers. And it is finally a decision which companies are able to do that job. Because as long the energy consumption, which is always decentralized where people work and live, the energy is promoted at very few places in the world, you need a long energy chain. And only multinational companies can organize that. And they came, and they are in a position to make whole nations and their governments dependent from them. That is the situation today. This touches democracy. This undermines democracy. This undermines the self-determination of an economy and of nations. This is a situation today. And therefore it is a question which goes far beyond only the debate on different energy technologies. and far beyond the conventional energy economic analysis. Because the most energy economic analyses are a result of the present energy calculations, and this is a result of the present energy system. That means if we look to the flow of the energy, this is the most important look. To the flow of the energy, we find a third fundamental difference between renewable energies and fossil atomic energies. The first difference, here you have exhaustible energies. On the other side, you have non-exhaustible renewable energies. As long as the sun exists. The sun will exist for 5 to 7 billion years more, tells us the astrophysics, not the astrology, the astrophysics. When one time I told this to someone, and he asked me afterward, did you say 5 billion or 5 million years? When I said it's 5 billion, then he said, I'm satisfied. Then nothing can happen. The potential is enormous. The sun delivers to our globe daily 15,000 times more energy than the daily consumption of fossil and energy is. The argument that there would be not enough potential is ridiculous, totally ridiculous. And I assume only the sun for California, the sun delivering, the energy delivering from the sun for California is more than 100 times more than the total daily consumption worldwide of conventional energy is. Therefore, this is not a question of potential. It's only a question which kind of technology we use and which way of calculation we have, which way of thinking we have, which structure of energy we want to have. And the second difference is here you have emission-free energies, and here you have the energies which create external effects, socially and ecologically. And more other external effects like the endangered energy security. And the third difference is a structural difference. With renewable energies, you have another energy flow. You have another energy density. And the change to renewable energies is fundamental. It's impossible to keep the same energy system which is tailored to the conventional energy deliverings and channel through this system renewable energies. That's impossible. You need another structure for that. And if you imagine what this shift means, you come automatically to other considerations about energy technologies and energy economy. Because it is a shift from few sources, few places, to a natural supply of renewable energies everywhere, of solar radiation, of wind, of other sources which are not everywhere, but which are at many places in the world, like biomass plantations, or like hydropower, or like geothermal power, or like wave power. Then it is away from commercial energies, from selling oil, gas, coal, uranium, to non-commercial primary energies like all the renewables with the exemption of biomass, because the biomass primary energy must be paid for the agricultural work which is behind that. That means it's impossible to shift from being a seller of oil, gas and coal to become a seller of solar radiation and wind. And that means the biggest economic sector in the world economy will disappear. if we go to renewables. That is the reason of the many resistances against renewable energies and the many denunciations of its potential, of its possibilities in general. No other reason. That is the origin of the resistances. And it is another origin, that is a way from few power stations or refineries to many in different sizes. It could be larger sizes if we take solar thermal plants, like we have it in California since the beginning of the 80s. Or to radical decentralization, like a PV device in the house, or like an integrated module, PV module into a mobile telephone. It is a way by that to new ownerships in the energy field, from few companies to many companies, to a widespread ownership. And it's a way to recreate energy autonomy practically for all. And therefore, it is also a way to calculate energy in another way. You have avoided fuel costs. You can avoid many infrastructural costs. But you have more initial costs. These costs can become compensated by all the other avoided costs, besides the avoided environmental costs. Therefore, it is necessary to create, to recognize this is another paradigm. And this recognition is the intellectual, the spiritual basis for the creation of a new energy system, technologically, economically, and politically. This, in some words, a basic consideration. Thank you very much.
Questions. I'm sure there's going to be a couple of questions from the audience after we have a raffle of two of the books, and if some more people are interested to read Hermann's book, we're going to have some books here to be sold.
Turn the switch to the mic on the side.
I'm sorry.
Yeah.
Oh, here. Hello? Well, we'll start. Any questions?
As you mentioned, there's non-renewable resources, but one of the concerns we have is that the quantities of coal and tar sands and heavy oils that are out there are sufficient to more than fill energy needs over the coming century. And the concern is that growth and use of those could continue to expand simply because it's so inexpensive to do so, except if you don't internalize the environmental costs. In thinking about the question of atomic energy, if we look at France, at this point they're less than 10% fossil. They have a fuel cycle that can be transitioned towards sustainable operation, and they closed their very last coal plant in 2004. In Germany, there's going to be some sustained reliance on fossil fuels. One question would be, because of the large carbon emissions that will come from that, why not close down coal plants before one closes down nuclear plants?
Because the decision between nuclear and fossil is like a decision between cancer and cholera. There are two different dangers, and we should not look only to the climate problem. Perhaps you remember what happened in California in the 70s. In the 70s, California was the leading region in the world, or the leading state in the world for pushing renewable energies. Many enthusiasm were there, articles, books, Solar California, and all of these things. And at this time, there was no debate about climate change. There were other reasons for that. clean air, to get clean air, to get energy security, to get independence from fossil fuels after the oil crisis, after the experience of the oil crisis. And I write in my book about 7 worldwide energy crises, all caused by nuclear or by fossil or by fossil energies. 7, not only 1. Climate change is 1. And if you only look to climate change, then automatically you have, then you can come to an answer, why not phase out first coal and second nuclear, perhaps, but then automatically. But if you look to the availability crisis coming, then nuclear has the same problems like fossil. If you think about, but perhaps if you would think about nuclear fusion in the future, but then you must think about, again, about another question. Is it a future to have nuclear fusion, which is much, the most optimistic views by the nuclear fusion protagonists show costs for energy which are higher than the present costs for renewables. Then is the question why we should go to fusion reactors, which doesn't exist, and no one knows if they would come to an operational power station. And such power stations would have perhaps 80,000, 100,000 megawatt in one plant. And this must be considered, is this good for a society? To have such a dependence from one technology. That means you need a reserve reactor. And Litsky, the former chairman of the American nuclear fusion program, says one time, even if we would have such a reactor, nobody will want it. And the most optimistic views are perhaps in 2050 there could be an atomic fusion reactor, but at this time we need the implementation of the energy chain. We cannot wait for fusion. And if we arrive at renewable energy, at a renewable energy basis, why we should leave that? There's only a reason to go to another energy source if there is a limit of the existing. Why we should do that? And if you look to the debate of nuclear fusion protagonists, what they say about renewables is under any intellectual level. They need the denunciation of renewable energies for legitimating their work with totally unscientific arguments, out of any practical experience and calculations. Therefore, the nuclear fusion is a non-option, practically. It's a non-option. And if you look to other things, to energy security, if you look to the water problem, which energy technology is the highest water consumer? It's nuclear. It's nuclear, no doubt. And France became an energy importer, an electric power importer, because each summer the days become more when they have to close most of their nuclear power reactors because the rivers have not anymore enough water, or the water is too warm for the cooling processes. And now imagine the transfer of such power reactors to other countries in the world. I don't think it is, the nuclear renaissance campaign is not well considered. Therefore, it's no reason to decide between. We have to decide to stop the present process. We have to decide to not between nuclear and fossil, but between nuclear and fossil on the one side and renewable on the other side.
Well, I was wanting to get into a little bit more about the politics, since you're in the German parliament in the EU.
Yeah.
And finer control of materials, which are basically called nanotechnology, but that plus automation plus a lot of technologies driving towards smaller scale of equipment that will have shorter lead times and feed into the smaller scale of distributed generation you're talking about. But you're saying there's also a lot of inertia from the large equipment manufacturers, and that includes tankers and things in the Middle East as nuclear power plants, all very large scale things. So how do you see the producers of a new diversified field of smaller scale equipment getting the research clout that's currently controlled by the large people?
The resistance of the conventional power sector, the conventional energy economy to renewables, I have explained the main reason, the basic reason. They cannot keep their structures if we go to renewables. They cannot keep the monopolistic role in supplying energy. That's impossible. And the primary energy sector will disappear. An oil company has a possibility to become an energy technology producer, but they don't have the chance to become a seller of solar radiation. And no one has this chance. And the way why we succeeded with the Renewable Energy Act and created the most dynamic process for renewable energy investments was that we did not leave the decision or this development to the energy companies. And we made a law against their veto, against their resistance. And the law is called Law for the Privilege of Renewable Energies in the Market. The basic elements of this law are three. First, a guaranteed access to the grid for each supplier of renewable energies, supplier of electric power. Even it is a very small one, even it is an owner of a 1 kilowatt peak photovoltaic device. And if he doesn't use it for himself, he can put it into the grid and he can sell it. Second, to give a guaranteed fee in order to overcome the second possibility to resist. Don't give him a fee, or only so low that he cannot risk an investment. The individual, the independent power player. And this guaranteed fee is not only one fee for all renewables, because the general target is to promote all renewables, to extend all renewables, because the general target is to replace the conventional energy mix by a renewable energy mix. And because the state of the art, the state of development and the state of the costs are different among the renewable energy options, we give different fees. And we prove the fees all 4 or 5 years. And the third element is no limitation in the introduction. Because if there would be a limit of the introduction to restrict this promotion only for, let's say, for 3,000 megawatt or whatsoever, then there is not enough incentive for the industry to invest in production facilities to produce windmills, PV modules, and so forth. They need a long-term perspective. And therefore, we avoided a restriction of the quantities. The door is open. And this created new factories for the renewable energy technologies, new companies, 150,000 new jobs in a very short run. a windmill industry with 60,000 new jobs, for instance. This created a very fast run to come to higher productivity. That means to lower costs. And this created a fast implementation. We implemented by this way 20,000 megawatt new installations in the run of 6 years. 20,000 megawatt. And if there would not be some states, we are also a federal republic, like the United States. And we have some states who are in favor of nuclear up to now with their governments, and they restrict intentionally the introduction of renewable energies by blocking permissions for the sites, for instance, for windmills. If there would be the same permission standard for all, like we have it in some states, we would have had the introduction in the last 6 years not of 20,000 but of 40,000 megawatt. That means it's a revolution what happens here. And the basic idea was not to leave it to the traditional energy sector. To stimulate, to give space for new investors who are not anymore obliged to ask the energy companies if they could do that. Free investments. Space for that. Political, economic space for that. This is the, and we can compare, if we compare such structures with other promotion policies for renewables, ours became by far most successful. All the others, which are more or less a compromise with the existing energy economy, the existing energy companies, did lead to by far lower results. But we should look to the most successful policies because we are in a race against time.
Unfortunately, we have only time for one more question.
Hi. You mentioned some secondary outputs like ecological impacts that fossil fuels have, and could you speak a little bit to the impact of having, heavy metals and all of these other not so safe things that make up wind and solar panels and batteries and storage, and also the availability of these products on to make this a large scale?
Even in ecological, in the ecological considerations, renewable energies represent another paradigm. We need a hierarchy, the conscious about a hierarchy of dangers. And it is out of any standard or measurement, intellectual measurement, moral measurement, to fight against a windmill because some people don't like the view of a windmill. To fight against this like fighting against a nuclear power reactor. This is, there is a difference, obviously, a huge difference. And it is not necessary to like windmills. Who likes power lines in the landscape? But with power lines, it is accepted that they are needed. And who campaigns against wind says indirectly it's not needed. Indirectly. If he knows that or not in this moment. And each blocked renewable energy investment for producing clean energy has nothing to do with protection of the landscape. We cannot speak about the protection of landscape when, because of the climate change, practically all landscapes are endangered by floods, by droughts, and if the glasses in the mountains start to smelt, if the Arctic ice smelts, if the Greenland ice smelts, no square meter on this globe is any more protected from the conventional energy. And even if there is no one, if no people live there. And this means we need the conscious about the hierarchy of dangers. Otherwise, we search to the last hair in the soup of renewable energies, and at the same time, the process of destroying the ecosphere is going on. Each blocked wind facility protects the prolongation of nuclear and fossil fuel production. That is the situation. Therefore, we have to take a decision. Which dangers are, tolerable and which not? Which problems are tolerable and which not?
So we'll have the raffle now, and I strongly encourage you to go up to Dr. Scheer afterwards and ask any more questions if you have any.